right, the normal curve, page 1. What do we do when it's not the empirical rule? All right, so we are looking for the probability like we did with the empirical rule, but the numbers do not line up exactly where the standard deviations do, so we can't use the empirical rule. We then have to use a calculator. Okay, so finding area probability, this would be like the probability of landing between these two numbers. We use normal CDF. We start at A, we end at B, we plug in our mean, we plug in our standard deviation. So that's how you would do that on a TI-83 or 84, or you can Google normal calculators on the internet and you'll find other things if you don't have an 83 or 84. There's plenty of free ones, don't have to pay. Okay, or going backwards, given the area, find the data values. So given the percentage, what is the A? Well, this is going the opposite direction, so this is an inverse. So this would be inverse norm, percent, mean, standard deviation. But the trick with this, very important, inverse norm on the calculator only uses the percent below. It does not understand percent in the middle. It does not understand percent above. It only understands the percent below that number. So we have to make some adjustments, and I will show you that in the examples. And then just a reminder, we're going to be using this again. So our z-score, x minus mu divided by sigma. And what that does is it takes every single normal curve, no matter the mean or the standard deviation, and centers it at 0. So then the z, we're 1 above, 2 above, 3 above, 1 below, 2 below, 3 below. So it just tells you how many standard deviations above or below the mean you are. All right, so example 1. At a certain college, the students have a mean IQ of 110 with a standard deviation of 5. So A, what is the probability that a student picked at random will have an IQ less than 112? So probability that X is less than 112, so we're going to do a normal CDF. We always have to have a left end, and so I just put 0, the smallest IQ there is, up to 112. It doesn't matter if there's an equal sign or not, because it's an area. So area, the line itself doesn't have an actual width. So it doesn't matter if it equals 112 or not, we still go to 112. We are told the mean is 110, the standard deviation is 5, and we get 65.5%. Okay, so B. What is the probability that a student picked at random will have an IQ between 118 and 122? So we're looking at this here. So normal CDF, we're going from 118 up to 122. The mean is 110, the standard deviation is 5, and we get approximately 4.7%. All right, so now here's where we're going to do that inverse norm stuff, where we go backwards. So 10% of the students have an IQ more than what? So 10% above, but again, I said big important thing here. Inverse norm only uses the percent below. But remember, the whole thing has to add up to 100% or 1. So if there's 10% above, that means there's 90% below. So I'm actually going to do inverse norm 0.9. Mean standard deviation, and we get approximately 116 for our IQ. Okay. So D, a little bit trickier. The middle 30% of students have IQs between blank and blank. So I drew my little curve down here. 30% in the middle, so I have A and B, so I need to figure out these two numbers. Well, remember, this is a symmetric curve. It's perfectly symmetric. So the whole thing has to add up to 100%. And if there's 30% in the middle, that means there's 35% on the left and 35% on the right, because those three numbers would add up to 100%. So to get A, we're going to do inverse norm of 35%, mean standard deviation, and we get 108. To get B, the calculator only understands percent below. The entire amount below B is the 30% in the middle and the 35% on the left. So to figure out B, we're going to do inverse norm of 0.65, then the mean, the standard deviation, and we get 112. So the middle 30% of students have an IQ between 108 and 112. And that ends page 1.